Terminal velocity of a car. Terminal velocity means the fastest velocity an object can reach. Even the most powerful rocket has a terminal velocity, and that's because when the velocity of an object increases, so does its drag. Drag is a force that acts in the opposite direction to motion when an object tries to move through a fluid. A fluid is something that can flow, such as liquids and gases. When an object moves through water, the drag is called water resistance, and when an object moves through the air, the drag is called air resistance. Water resistance and air resistance are very common forms of drag. What causes drag? When a force acts on an object and makes the object move through a fluid, particles of the fluid hit the object's surface, causing an opposing force that we call drag. So now the object has two forces acting on it in opposite directions, which will cause a resultant force. And according to Newton's second law, if there's a resultant force acting on an object, it will affect its velocity. I'll give you an example to explain what I mean, and I'll show you a velocity time graph so you can see how resultant force and acceleration are connected. The slope of the velocity time graph tells us the acceleration. If it's a steep slope, it's a big acceleration. If it's a gentle slope, it's a small acceleration. And if the slope is flat, there's no acceleration. Here's an example of a drag racer. Well, that all happened a bit fast, so let's pause it and break it down so we can understand what's going on. At first, the car is stationary. The driver starts the engine and puts their foot on the accelerator, which provides a large constant force forwards. There's not much air resistance backwards because the car is only just starting to move forwards. Newton's second law states, if there's a resultant force on a mass, then it will accelerate. F equals m times by e. Since the car has a big resultant force forwards, this causes a big acceleration, as shown by a steep slope on the velocity time graph at position 1. As the car's velocity continues to increase, the air resistance increases, so the resultant force forward is not as big as it was, and the acceleration is now less, which we can see by the flatter slope on the velocity time graph at position 2. The velocity continues to increase until the drag force backwards becomes the same size as the engine's force forwards. At this point, the forward force and backwards force cancel each other out, and the resultant force becomes zero. So the car moves with a steady speed, which is Newton's first law. If you look on the graph at position 3, you can see the slope has gone flat, showing us there's no acceleration and the velocity has reached a steady maximum value. This is the terminal velocity of the car. I hope that was helpful. Smash that subscribe button, work hard, be nice, bye for now.